Hello friends, my name is Tejendra Jangir. Here I am discussing the object. Here I am discussing the solution of Assistant Executive Engineer previous year paper. Next video is coming soon for the further solution of this paper, and coming soon solutions are previous year paper of engineering, power electronics, P.S.Bimbhra, AFT Matthew and OSIDQ, electromagnet SOMS outline series, signal system, SOMS outline series, and many more. So don't forget to subscribe my channel, that is anybody can download education at ABCD Education. Okay. Now come to the question number 57. For complete production of the three-phase line, we what we use: three-phase relay, two-phase relay, one trip earth fault relay. Now come to the solution. We use different differential production, but in the differential production we cannot detect the line to line fault, triple line fault, uh, by the help of differential production. But so to for the complete production of the generator transformer, we use two phase and one earth fault relay. This will provide complete production of equipment. Okay, so the correct option is 4. Now come to the question number 58. For the 20 bus power system with one voltage control bus, the size of Jacobian matrix is. These are the option. Now come to the solution. In 20 bus system, we take one is the voltage control bus, so it is also known as PV bus. If PV bus, which is in all power system, one is must be slack bus, so we take it is we take so it is the slack bus. Okay. Now remaining buses are 19 bus, which is must be PQ buses, also known as load bus. Okay. Now, in this PQ buses, number of P is specified, that is equal to L, which is 19. Okay, and number of Q is specified, that is equal to M, so it is 19. So the total size equal to L plus M. Okay, so that is 38. So size of matrix is Jacobian matrix is 38 is to 38. So the answer is 4. Now come to the question number 59. The severity of line to ground and three-phase fault at a terminal of an unloaded synchronous generator is to be same. Okay, if the terminal voltage is 1 per unit, that is Z1 Z2 equals to uh, point 1 per unit, and Z2 equals to J point 005 per unit for the alternator, then the required inductance for the neutral grounding. Okay. Now come to the solution. We know that the three-phase fault current, which is equal to 1 per unit voltage divided by Z1 positive sequence impedance. Okay, so the three-phase magnitude of fault current is equal to 10 per unit. Now for the single line to ground fault, these are positive sequence component, and this is the negative sequence component, and this is the zero sequence component. In the zero sequence component, the neutral uh, the grounding reactance, that is 3 times of Zn. Okay, so now we find out the IA node, that is zero sequence current. Okay, now the fault current IA equals to 3 times of this current, zero sequence current. So now put the values of all Z1 Z2 and Z node plus 3 Zn now, uh, and this will equals to single line to ground equals to three phase code, as mentioned in the question. So Zn equal becomes 0.0166 per unit. Okay, so the answer is first. Now come to the question number 16. Two insulator discs of identical capacitance value C makes up a string of a 22 kVA 50 Hz single phase overhead line insulation system. If the pin to earth capacitance is also C, then the string efficiency is. Now come to the question solution. This is the arrangement as mentioned in the question. Okay, now we take it, this is the V1 voltage and this is the V2 voltage. This is the I2 current, which is divided into two component, that is I1 and this is the I1. Okay, now I2 equals to I1 as the nodal analysis. Okay, now V2 equals to V2 I2 current, that is omega C V2, and I1 K omega C V1, and I1, that is omega C V1. Now V2 becomes 1 plus K V1. Now we know that efficiency is total voltage divided by number of stream multiplied with the last conductor voltage. Okay, so now put the value of V1 plus V2, then it will becomes 2 plus K equals to V1, and put the value of V2, then we get 2 plus K divided by 2, 1 plus K, then put the value of K, that is 1. Now we that is become 3 by 4, which is 75%. Okay, so the answer is 2. Now come to question number 61. For the accurate load flow calculation on the large power system, in the question large power system, the best method is for the large power system and accurate value, accurate load flow calculation, we use only Newton Raphson method. Okay, so the answer first is correct. Now come to the question number 62. A short circuit occur in a transmission line, transmission line next to the line capacitance. Okay, when the voltage wave is going through zero, the maximum possible momentary short circuit current corresponding to, this is simple question, but the concept is very important. We know that the current is divided into two component. First is the DC component, and the second is short circuit current. Okay, so due to the doubling effect at the time of starting, at the time of starting fault current. Okay, due to the sub transient component, it's uh, it's twice of symmetrical short circuit current. So the answer is first. This is twice. Why? Because of doubling effect. Okay, and why it is twice? Because of sub transient component. Okay, now come to the question number 63. For the power transformer, positive sequence impedance is more than negative sequence impedance and zero sequence impedance. Positive sequence impedance, negative sequence, and zero sequence impedance are equal. For the power transformer, all sequence impedance are equal to each other. Okay, so this thing you have to remember. Okay, now come to the question number 64. The rate of rise of restriking voltage depends upon, these are the options. Now come to the solution. We know that the maximum value of restriking voltage, that is 2 into E peak, and the value of, so the this rate of rise of restriking voltage, that is also known as triple RV. So by differentiating the voltage E, we get this. Okay, so omega n E sin omega n T. Okay, so omega n is dependent on the omega n equal to 1 by root LC. Okay, in the circuit, so it is depend on the inductance and capacitance both. Okay, so the answer is 4. Now come to the question number 65. For the production of the parallel feeder fed from the one end, the relay required are. Now come to the solution. These are the options. Now come to the solution. We know that this is the generation, and at the generation end we use non-directional relay as mentioned in the question, that is as mentioned in the solution, that A and J are the non-directional relay, but at the load end we use directional relay. So the answer is first, non-directional relay at the source end and directional relay at the load end. Okay, now come to the question number 66. A generator is connected to the synchronous motor. A generator is connected to the synchronous motor. For the stability point of view, it is preferable to have. In this type of neutral grounding, the neutral of the system is connected to the ground through the one or more resistance. Resistance grounding is limit the fault current. It protect the system from the transient over voltage. Resistance grounding declare the arcing grounding risk and permit the ground fault protection. Okay, so the resistance grounding must be used in the generator. Okay, And the to minimize the transient over voltage, the ground fault transient over voltage, the fault current in the reactance grounded system should not be less than 25%, and the three phase fault current